Assalamu alaikum everyone, I hope you're all well. So I'll be solving difficult questions from October-November 2024 papers in this session for IGCSE and O-Level Art Maths. I hope this is helpful. You can find other videos like this from other recent papers in the playlist that is added to the description below as well. You can find difficult questions from 2022 papers, 2023 papers. I'll be trying to do it for the 2024 papers today, inshallah, in multiple streams. So let's begin with this. If you have any quick questions, you can also, keep posting them in the live chat on the side. All right, so let's begin with this. It says, first of all, so these are from November 2024 papers. Okay, so this is the first part of this. I'll be doing another part in which I'll do the rest of the questions then. Let's start with this. It says, the curve y equals a cos of bx plus c, where a, b, and c are integers. It passes through the points minus pi over 6 and minus 2. And there's another point, this. The curve has a period of 2 pi over 3. We need to find the values of a, b, and c. Now, how can we do that? First of all, we are given that the period is 2 pi over 3. Now, it's a cos function. What's the standard period of a cos function? It's 2 pi, right? The period is being divided by 3. What does that tell you about this number here? X should be multiplied by 3 because that will make the period get divided by 3, right? So this period, since it's being divided by 3 here, that tells us that the value for b, that is supposed to be 3, okay? So value of b turns out to be 3 from this. Then we're given 2 points that lie on this function. For that, all we have to do is just input these points in this equation, and that is going to give you the values of a and c. Let's try that. So now that we know the value for b, we can say this is a cos of 3x plus c, right? That's what the equation is going to be. Let's input each of those points one by one. One point is minus pi over 6 and minus 2, and the other point is pi over 9 and 1 over 2. Let's input these points here and see what we get from this. So this gives us minus 2 equal to a cos of 3 into minus pi over 6 plus c. Now you can just input this in your calculator directly and see what that gives you. Cos of, make sure your calculator is in radian mode. First of all, you have to be careful about this. Look at the top of the screen. It says D here right now. It should be R. Let's change it to that. Angle unit has to be radian. Now let's input that in our calculator. Cos of minus pi over 2. Let's see what that turns out to be. So you have a calculator paper tomorrow, right? So that means you can just input this in your calculator directly, and that's giving me 0. So the value for c turns out to be negative 2 from this. So now that we know the value for c as well, let's look at what happens when we input this point. Y is 1 over 2. The value for a is what we have to find out, into cos of 3x, that means 3 pi over 9, plus c. The value for c is minus 2. We could just input that here as well, and that is going to give us the value for a. Let's simplify this and see what we get from this. 1 over 2 equals a into cos of pi over 3. You can evaluate this on your calculator, although I hope you just remember these values now as well, because you have to memorize them for your paper 1 anyway. Cos of pi over 3, you just put that in your calculator, and that should give you 1 over 2 from that. Okay, so you can try that on your calculator as well, and that will give you this. Now minus 2 goes to the other side, it becomes 5 over 2 equals a over 2, and the value of a that you end up getting from that is 5. Okay, so that's what we were looking for. A is equal to 5, c is equal to minus 2, and b is equal to 3, and that's your final answer. Now in the second part it says, find the least value of y on the curve for x between 0 and pi over 2. Now, how do you find the least value of y? So it's very similar to finding the range of a function, right? We're looking for the minimum value for y, okay? How can we find that? So now that we know the values of a, b, and c, we can write that function in this form. We can say y is equal to 5 cos of 3x minus 2, right? That's what this function is now. What's the least value of this function? How do we think about this? This is what the graph of cos looks like generally, right? The standard cos graph that looks like this. The least value of this function comes at pi, and that value is minus 1. Now, is that value going to be in this interval? That graph is for cos of x. This is cos of 3x here. 3x means the period is divided by 3 in this case, right? So original period was 2 pi. The period for this transformed graph is 2 pi over 3. So that means this value that was earlier occurring at pi, now that value would actually go to pi over 3, right? So that does fall in this interval. So we know that the value minus 1 is falling in this interval, as in when cos is minus 1, that point is falling in this interval. All we have to do is just input this whole thing as minus 1 and see what value of y you get from that. Let's try that. It becomes y equals 5 into minus 1 minus 2, and the value that I get from that is minus 7. That's the least value. That's the least value of y that we get from this. Now, what's the value of x at which this occurs? How do you find that now? At what value of x does this occur? We figured that out already before. Since we know in the standard graph that value would occur, when x is equal to pi, right? Now, in this case, since the period has been divided by 3, every point, its x coordinate would be divided by 3, right? So it was at pi earlier in the standard cos graph. In this transformed graph, this value would now occur at pi over 3. So the corresponding value of x that we have from this is pi over 3. That's what we write down there. The minimum value of y is minus 1, and the value of x that we get corresponding to that is going to be at pi over 3. Okay? So this value would now go to pi over 3. All right, let's move on. Let's move on to the next one. This was first question. The second part was a bit tricky. That's what I wanted to discuss in this question in particular. Let's have a look at this. Now, this is something that's coming quite frequently in the recent papers, that you have to sketch these cubic graphs. How do you do this? It says find the coordinates of the stationary points on this curve. It's a cubic function. How do you find that? Stationary points, we find them using differentiation. How do you differentiate this? One idea could be that you use the product rule, and that will work. You can do it that way if you want. Or you could also just simplify this first and then differentiate it. That will, make things slightly easier, I think, because you would not have to use the product rule anymore. You can just simplify this expression. So this is 2x minus 5, x minus 1 whole squared. What's that? You can say that's x squared minus 2x plus 1, right? A squared minus 2ab plus b squared. Let's simplify this further, and that gives us 2x cubed minus 4x squared plus 2x minus 5x squared plus 10x minus 5, and this simplifies to 2x cubed minus 4x squared minus 5x squared. That becomes minus 9x squared, and then plus 12x minus 5. This is what f of x is. We are looking for the stationary points. How do you find stationary points? You find the derivative, put that equal to 0. Let's do that here. Let's find the derivative, put that equal to 0. What's the derivative? Let's differentiate each term separately. Derivative of 2x cubed, that would be 6x squared. Derivative of minus 9x squared, that's minus 18x plus 12, right? You put this derivative equal to 0 now because you're looking for the stationary point. For the stationary point, you just put this equal to 0. And that gives you this equation. Let's solve this equation. It's a quadratic equation. We could first simplify it like this. Divide the whole thing by 6. So you have x squared minus 3x plus 2 equal to 0. Can we factorize this? We could write this as x squared minus 2x minus x plus 2 equal to 0. We get two factors from that, x minus 2 and x minus 1. So x either equals 1 or equals 2. These are the x coordinates of the stationary points. That's one thing that we were looking for. What about the corresponding y coordinates now? We've got this function here. Let's input these values back in that function and see what you get from that. Corresponding y coordinates. This is the function. F of x is equal to, or it's actually used this form. No, not this. This form. That will be slightly simpler to work with, I think. Let's do that. F of x is equal to 2x cubed minus 9x squared plus 12x minus 5. Now in this, you just input x equal to 1 once, and then you input x equal to 2 and see what corresponding values of y you get from that. Okay, so what happens when we input x equals to 1? Let's see what we get from that. We could just do that mentally as well. 2 plus 12 is 14. 14 minus 14, that's giving me 0. So when x is equal to 1, y turns out to be 0. When x is equal to 2, what about that? Let's just input that to be sure. 2 into 2 cube minus 9 into 2 squared, which is 4, plus 12 into 2 minus 5, and that's giving me minus 1. That's the other point that we're getting. So one stationary point is 1, 0, and the other stationary point is 2 and minus 1. And that's what we were looking for. These are the coordinates of the stationary points of this function. Okay, now the second part says, on these axes, sketch the graph of y equals f of x, stating the intercepts with the axes. Now, how do you draw the graphs of cubic functions? Cubic functions have 4 possible shapes. Okay. Cubic functions have 4 possible shapes. They can look like this, 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 or this, right? Now the shapes on top, they come when the coefficient of x cube is positive, which is what we have in this case. The coefficient of x cube is positive here, right? So we're going to have the shapes on top there. Okay, one of these 2 shapes. Now, which one of these 2 is it going to be? The left one, because we've got multiple intercepts for this, right? We've got multiple intercepts, multiple x-intercepts. How do we know that? How do you find x-intercepts? You put y equal to 0. The x-intercepts for this function, if we input y equal to 0, they would be x equals 5 over 2, which is 2.5. or x equals 1. These are the 2 x-intercepts that we've got for this function. Now we've got to be careful. X minus 1 whole squared, this is coming, it's a repeated root, right? So at this particular point, we have a repeated root. That means we would have a tangent at this point. Now let me explain what that means. So first of all, we know it's going to be the shape on the left side, because the shape on the right, this one, this can only have one x-intercept. It can't have multiple x-intercepts. If you have multiple x-intercepts, the only possibility is that it's this shape. Okay. Now, how exactly do we draw that shape? We have these 2 x-intercepts, 1 and 2.5. Let's mark those 2 points here. Let's mark this as 1. And then this might be 2, this might be 3. The 2 x-intercepts that we have are at 1 and 2.5. This is one x-intercept, this is another x-intercept. Okay, now 1 is a repeated root. 1 is a repeated root. So we would have a tangent at the point x equals 1. At x equals 1, we're going to have a tangent, and that will look like this. Since the shape has to be like this, right? If at 1 we have a tangent, the graph should go like this on this side, and then it goes down there and goes up like this, right? Roughly, that's what the shape is going to look like. I'll just draw that slightly better than this so it looks smoother. It's going to look like this. That's what the shape of the cubic function is going to be like. All right, and now you can mark those points as well. We know one stationary point is at 1, 0. We already know that as well. So we've already shown that here. The other stationary point is at 2, minus 1. So we have to be careful about that as well. The other stationary point that should have actually occurred at 2. So let me draw a stationary point at this position here, so it would look like this. The curve goes below such that it has a stationary point at 2, and then it changes direction and goes like this. Okay, so we have these two stationary points as we found in the first part, and the x-intercepts, this is 1, this is 2.5. Y-intercept, what about that? What's the y-intercept going to be? This constant, that's -5. The y-intercept of this graph is going to be at -5. So this point here is -5. That's what the graph of this function is going to look like. Okay, let's move on. That was part B. Now it says, hence find the values of k for which f of x equals k has exactly one solution. Now what does that mean? F of x equals k has exactly one solution. How do we think about this? We've got two functions. One is on the left side of this equation. You can say that's y equals f of x. We've already drawn that function here. That's this function y equals f of x. And we have another function on the right side. This is y equals k. What kind of line is that? It's a horizontal line, right? Y equals something, y equals some constant, that's a horizontal line. Now, what horizontal line on this graph would only give you one solution, would give you exactly one solution? Where would you draw such a line such that you only have, or you exactly have one solution? Now, let's think about this. Let's think about this. If I were to draw a horizontal line here like this, how many solutions does it have? 1, 2, 3. That's not what we want. We only want one solution, right? Okay. If I were to draw a horizontal line here, what about this? This horizontal line? This is intersecting at only one point. Okay. Now I can keep going up and up. If I just touch this turning point, then I have two solutions. That's not what I want. So I have to be below that turning point, right? That's one condition that I have. It has to be below that turning point. Okay, what else? Another possibility is that you're on top there, above the x-axis. In this region as well, you have only one point of intersection with the curve. So there are two possible cases that we have here. One is that that horizontal line could be in this region above the x-axis, or it could be below that turning point. Okay. So what are the possible values of k then? Above the x-axis, you would say k could either be greater than 0, right, in this region. The horizontal line could either be above the x-axis like this, or it should be greater than 0, or there's another possibility that you are below this turning point. You are below this turning point. Now, what's the y coordinate of the turning point? We found that there. That was -1. Okay, so that's -1. Okay, we actually should have been a bit more accurate with that graph. Actually, let's do it once more. You always do it with a pencil. So I'll take that point a bit up there. Doesn't make much difference though. In your sketch, they would not deduct marks for that, but it's better to be more accurate. You have -1 here. So you can say this is the other region that you have below -1. Okay. So you would say k is less than -1. It's either the first case or the second case. You can write that with a comma in between, or you could just say or as well. Okay. So these are the two possible positions of that horizontal line. It could either be greater than 0 or it could be less than -1. Only in these two cases, you would have exactly one solution. Okay, let's move on. Okay, this is another question from this paper that was relatively more difficult. Let's have a look at this now. The first three terms of an arithmetic progression of an AB, they are 2 tan 2x, 5 tan 2x, 8 tan 2x. Find the values of x where x is between -180 and +180, for which the sum to 30 terms is 455 under root 3. Okay, now how do we think about this? It's an arithmetic progression, right? It's an arithmetic progression. That's one thing that we know. And the sum of the 30 terms is 455 under root 3. Now, how exactly do we think about this? Now, if it's an arithmetic progression, how do you find the difference? What is the difference going to be? You could subtract this first term from the second term, or the second term from the third term, any of them, that should work. So difference is going to be 5 tan 2x minus 2 tan 2x. What does that simplify to? That simplifies to 3 tan 2x. That's the difference. What about the first term? The first term is 2 tan 2x, and it's an arithmetic progression. Okay. We are given something about the sum of this arithmetic progression. Do we know the sum formula? Do we know the sum formula? Walaikum assalam. What's the sum formula? It's 1 over 2 times n into 2a plus n minus 1 times the difference. That's the sum formula for an AB, right? Let's just input values. They're saying that sum of the first 30 terms is this. Okay, so we could say S30, let's find that. Using the information that we have, we can say this is 1 over 2 times 30 times 2 into a. What's the value for a? 2 tan 2x plus n minus 1, that means 29, or you could say 30 minus 1, times the difference. The difference is 3 tan 2x. They are saying that this should equal 455 under root 3. And now we just have to solve this equation. So we have 455 under root 3, that equals 15 times 4 tan 2x plus 29 times 3, that's 87 tan of 2x. Let's simplify this further. 15 into 91, right? 15 into 91, let's see what that is. That's 1365. 1365 tan of 2x, that equals 455 under root 3. And from that we get that tan 2x equals 455 divided by this. That's 1 over 3. So we have under root 3 over 3. Tan 2x equals under root 3 over 3. This is the equation that we now need to solve. How do we solve this equation? The interval that we're given is for x. The angle that we have here is 2x. So we have to adjust that interval. One way to solve such equations is that use a substitution that makes things simpler to understand. You could say, for instance, let's use this substitution. Let a equals 2x. The interval that we were given for x, that was from minus 180 to plus 180. Let's write that down here. Minus 180 to plus 180. Now, if we want to solve this in terms of a, we have to adjust the interval as well. What's the interval going to be? Input minus 180 there. The value for a that we get, that's minus 360. Input plus 180 here. The value for a that we get is plus 360. So a is supposed to be between minus 180 and plus 180. Minus 360 and plus 360. So now we solve this equation in terms of a and see what that gives us. Tan of a equals under root 3 over 3. Find the basic angle, see what the basic angle turns out to be. Let's do that. We can say tan of alpha equals under root 3 over 3. You could put this on your calculator. Again, since it's a calculator paper, you could do that. Otherwise, you should also remember, where do you have tan under root 3 over 3? This is at 30 degrees. Okay, you can just confirm this on your calculator as well. Make sure your calculator is in degrees mode for this question now, because the angle that's given in the question, that's in degrees. So you need to make sure your calculator is in the correct mode. Let me do that. Tan inverse of under root 3 over 3. Let's see what we get from that. That's 30 degrees, right? That's the basic angle. Now the basic angle is 30 degrees. Let's find the corresponding values of a from that. It's tan, so it's supposed to be either the first quadrant or the fifth or the third quadrant. Basic angle could either be here or it could be here. One possible angle that we're getting is this. So we could say a equals 30 degrees, or we could go to the third quadrant. That gives us another possible value, which is going to be 180 plus 30. That's 210. That's the second value that we're getting. And then if we go beyond that, we would go outside the interval, right? We can't go beyond that. We'll go outside the interval. The maximum possible values is 360. We can't go beyond that. Okay. However, the interval also has negative values. So we also need to go in the clockwise direction and see if there's any possible answer in the clockwise direction. Let's do that now. Let's go in the clockwise direction. This is the first possible angle that we're getting in the clockwise direction. What's that angle? That's 180 minus 30. But since we're going clockwise, we put a negative sign with that. Another possible value could be that we go all the way here to that other angle. What's that? That's 360 minus 30. Again, we're going clockwise. We put a negative sign with that. So these are the four possible values of A that we're getting: 210 minus 150 minus 330. Okay. Now we put that substitution back. A was equal to 2x. Let's put that substitution back. We get 2x equal to 30. 2x equals this, 2x equals this, 2x equals this. And that gives us the four possible values of x. X is either equal to 15, or it's equal to 105, or it's equal to minus 75, or it's minus 165. These are the four possible values of x that we're getting, and that's our final answer. Okay, so adjusting this interval is very important. Otherwise, you would miss out on some possible solutions. If you just use this original interval, you would miss out on some solutions. So you need to make sure that you always adjust the interval like this. You can use a substitution like this. That makes things easier to understand. You can do it without substitution as well. However, adjusting this interval is necessary. If you don't do that, you miss out on some possible answers. And of course, you lose marks because of that. Okay, so that's our final answer. That was part A. Now part B says, the first three terms of a GP, the first three terms of a geometric progression, they're given like this. Now that looks fairly complicated, quite squarey. How do we think about this? They're saying find the values of theta for which this geometric progression has a sum to infinity. Now when does the sum to infinity exist? What's the condition that we've got for that? The condition is that ratio is supposed to be between minus 1 and plus 1. For the sum to infinity to exist, ratio has to be between minus 1 and plus 1. Okay. What's the ratio? Can we find the ratio from this sequence? Let's do that. Let's find the ratio. We could divide the second term by the first term to find the ratio. Let's see what we get from that. 20 cos raised to the power 4 theta. 20 cos raised to the power 4 into theta minus pi over 2 divided by 5 cos squared into cos square of, not multiply, cos square of theta minus pi over 2. 20 over 5, what does that give you? That gives you 4. Cos raised to power 4 over cos square, that's just cos square. 4 cos squared in 4 cos square of theta minus pi over 2. That's the ratio that we end up getting from this. Okay. Now this ratio has to be between minus 1 and 1. All right. So the ratio 4 cos square of theta minus pi over 2. This is supposed to be between minus 1 and plus 1 for the sum to infinity to exist. All right. Now, how do we think about this further? It's cos square. Okay, it's cos square. Let me just divide by 4 on the other side first of all. Divide the whole inequality by 4 and see what we get from that. We get cos square of theta minus pi over 2. That is between minus 1 over 4 and plus 1 over 4. What I've done is I've divided the whole inequality by 4, and that's what you get from this. Okay. Acha. How do we solve this further? Ashia, I'll see that later. Have you WhatsApped me? I'll have a look at that. Okay, so cos square is between minus 1 over 4 and plus 1 over 4. Now, this is a square. A square can never be negative, right? A square can never be negative. So this is actually equivalent to saying, we could say if cos square is between minus 1 over 4 and plus 1 over 4, this condition is kind of redundant. It doesn't make any difference, right? On the lower side, there's no condition as such because cos square cannot be negative. Or another way to think about this is that you could say that cos square is just between 0 and 1 over 4 because it can't be negative. A square cannot be negative, so we cannot even go in the on the negative side. The least possible value that cos square could possibly have would be 0. It can't go below that. Okay. This condition, as I said, is kind of redundant. Any square is always going to be greater than or equal to 0. So you have it or don't have it, it doesn't really matter. The main condition that you have is on this side. That's the key condition that actually matters. The other side, as I said, it does not even matter because whatever the value is, it's always going to be greater than or equal to 0. So let's focus on the right side of this inequality. How do we solve this inequality? That's the question now. For solving any kind of inequality, what you should do is first treat this as an equation. Okay, treat this as an equation and see what you get from that. So treat this as an equation. So the inequality that I want to solve now is cos square of theta minus pi over 2, that's less than 1 over 4. That's the inequality that I want to solve here. Okay, treat this as an equation first of all and find the critical values, the cutoff points from that. Okay, let's do that. Treat this as an equation and solve that equation first. Let's see what we get from that. Cos square of theta minus pi over 2, that is equal to 1 over 4. All right, what do we do now? We could take square root on both sides. Let's take square root on both sides and see what we get from that. Cos square of theta minus pi over 2, that equals, when we take square root, the square gets removed from there. Cos of theta minus pi over 2, that is equal to plus minus 1 over 2. All right. What about this now? Cos could be either positive or negative. That does not matter. So that means it could be in any one of the 4 quadrants. All the 4 quadrants are possible. We could have the basic angle here. We could have it here. We could have it here. We could have it here. Let's find that basic angle. Cos alpha equals 1 over 2. What's the basic angle? When is cos 1 over 2? It's supposed to be in radian. It's at pi over 3. 60 degrees or pi over 3. You can confirm this on a calculator as well. The basic angle turns out to be pi over 3. Okay, that's the basic angle that I get from this. All right. Now, this basic angle could be in any one of these 4 quadrants. So what are those possible angles that we get in each quadrant? In the first quadrant, we have pi over 3. That's one possible value. Okay. Now, what is that equal to? The angle was theta minus pi over 2 here. Theta minus pi over 2. Now, again, if you wanted to do a substitution here, that's perfectly okay. You could do that. Or you could do it directly like this as well. Both will be fine. This is one possible value of theta minus pi over 2 that we're getting in the first quadrant. Okay. What about the second quadrant? In the second quadrant, we would have pi minus pi over 3. Okay. Pi minus pi over 3. That's the second quadrant. Similarly, we can have more values of theta. Theta minus pi over 2 could equal in the third quadrant this thing here. That would be pi plus pi over 3. Or in the fourth quadrant, what would that be? In the fourth quadrant, it would be this, which is 2 pi minus pi over 3. And all of them are going to give you different values of theta. So there are 4 values that we're getting from this. Let's see what those 4 values turn out to be. Okay, let's find those 4 values and see what we get from that. That's a 6-mark question. That does require quite some working. Let's find these values. Pi over 3 plus pi over 2. Let's see what we get from that. Pi over 3 plus pi over 2. And that's giving me 5 pi over 6. That's one value of theta that I'm getting. Then in the second quadrant, I had 2 pi over 3 plus pi over 2. And that's giving me 7 pi over 6. That's another value of theta that I'm getting. Then in the third quadrant, I have pi. Okay, now what was the interval for theta? Theta's interval was this. 7 pi over 6 and minus pi over 6. So we had to be a bit careful here. We had theta minus pi over 2 there. Okay, I did not take into account that interval. I should have done that. Let me write that down here. Theta minus pi over 2. What should be the interval for that? Theta minus pi over 2. Let's adjust that interval as well. Minus pi divided by 6. That was the original one that was given. Minus pi over 2. When we adjust that interval, this is going to be between minus 2 pi over 3 and 7 pi over 6 is the upper limit, and that would actually become 2 pi over 3. Okay, so the values that we have to consider on quadrants have to be within this interval. Okay, let me actually go there. First and second are fine, but then 2 pi over 3 was the limit. So the third and fourth quadrants, for them, we would have to go in the negative direction, okay, because they are going outside the interval. Interval is from minus 2 pi over 3 to plus 2 pi over 3, right? The first and second quadrants, they are going to be considered from positive side. For the third and fourth quadrants, we'd have to go in the negative direction like this. So this is one angle that we're getting. This is another angle that we're getting. So they would be, instead of these, for the first one, for the fourth quadrant, this would be minus pi over 3. That's one value that we would consider. And for the other one, that would be pi minus pi over 3, but in the negative direction. So that is going to be minus pi over 3 plus pi over 2. Let's do that first calculation. Minus pi divided by 3 plus pi divided by 2. And that's giving me pi over 6. That's another value of theta that I'm getting now. And then the last one, what's that? That's minus 2 pi over 3 plus pi over 2, and that's minus pi over 6. These are the four possible values of theta that we're getting. Okay, these are the four possible values of theta that we're getting from this. Now, these are the solutions of this equation. But we were not solving this equation, we were actually solving this inequality. This inequality was what we were actually solving. So what are the solutions of that inequality now? That's what we need to figure out. Now, how do we do this? One way to do this is using a number line. That's what I recommend, because you don't have to think about that so much. You can just write down. There's some calculation involved, yes, but it'll be pretty quick after that, and it works for most inequalities, almost all the inequalities that you'll find later on in A-levels as well, the number line method, and that works like this. You just mark those points there. One is minus pi over 6 in order, right? So minus pi over 6, that's the smallest value. Then the next value is pi over 6. Then the next value is 5 pi over 6. And then the next is 7 pi over 6. Okay, so what we can do is, now we can say these are the critical values, the critical points that we've got by solving this as an equation, right? Now, these points divide your number line into multiple regions like this. You can see which regions satisfy this inequality, and you would write down the solutions based on that then. Now, What do we mean by that? Let's think about this. Let's just input this in our calculator. You take one number in each of these regions. So you've got these different points. These are the critical points: minus pi over 6, plus pi over 6, 5 pi over 6, 7 pi over 6. Take one number in each of the different regions that you have in this number line. One region is on the left side here, there's another in the middle, another here, and another on the right side. Take one number in each region and see if that satisfies that inequality or not. Okay, so one number that's to the left of minus pi over 6, you could say, for instance, just any number, it doesn't matter what specific number that you're taking there. I could say, for instance, let's take minus pi over 2 there. In the middle, and between minus pi over 6 and plus pi over 6, I could try 0, for instance. Between these two, I could say, let's do pi over 2. Between these two, I could say, let's try pi. On the right side, let's try 2 pi, right? Let's try these numbers and see which ones satisfy that inequality. Now, you just have to do this on your calculator. Don't need to show any working for this. Just input these values one by one on your calculator. So you have cos of theta minus pi over 2. So in place of theta, you could input minus pi over 2 minus pi divided by 2. And then you have minus pi over 2 as it is already. And then you square that whole thing. Right? That's cos square of this. What do we get? We get 1. Does that satisfy this inequality? Is 1 less than 1 over 4? It's not. That means this region is not correct. Okay. Then you could try 0. Use 0 here. What about that? Is 0 less than 1 over 4? Yes, this satisfies. Then you try pi over 2. Is 1 less than 1 over 4? No, this does not satisfy. Then you have pi. That's 0. 0 is less than 1 over 4, so that satisfies the condition. Then the right side, 2 pi, that's 0. This also is satisfying the condition. Cos square of 2 pi minus pi over 2, that is also less than 1 over 4. Okay, we actually should not try a number that's far away because we're going up to 7 pi over 6. Okay, we have to stay inside that interval, so we don't have to go beyond that. We only have to stay inside that interval between minus pi over 6. Okay, let's actually not consider these because these are not needed. The only intervals that we need are in the middle. I'm sorry about that. So since the condition is theta is between these two values, we don't have to check beyond them. So that actually simplifies our working. We only have these 3 regions to check: 1, 2, and 3. So just check these 3 regions and that's enough because the interval that's given is between minus pi over 6 and 7 pi over 6. We don't have to go beyond that interval. Okay. All right. So now we have these regions satisfying the inequality, this region and this region. These are the regions that satisfy the inequality. All right. Now we could just write down the answers based on this. We could say theta, it has to be between these two numbers. That's one possibility, minus pi over 6 and plus pi over 6. And the other possibility is that theta is between these two numbers. That means it's between 5 pi over 6 and 7 pi over 6. Now let's check for the equality conditions. Was it supposed to be equal to or just greater than? Okay, so these points are included. All right. Minus pi over 6 and 7 pi over 6 are included, but at these values, we were getting exactly 0. So we would not consider that. All right, what else? Theta had to be within that interval. Okay, so these are the values that we get. Theta is between these two values and between these two values. Okay, and that's your final answer. This is what you wanted to find out here. This will be fine. This will be fine. However, if you want to be more accurate, if you're aiming for that distinction, in this case, you can think of it a bit more. It's a geometric progression. It's a geometric progression. Now, since it's a geometric progression, what that means is the ratio between consecutive terms, it has to be constant. However, there are some values of theta here that could be a bit problematic. For instance, if you input a value for theta at which this value becomes 0, then all the terms are just going to be 0, 0, 0, 0, 0. And that's not interesting, right? 0, 0, 0. That's not a standard geometric progression. So you could exclude the points where this thing would become equal to 0. Okay, now where does that happen? When is cos equal to 0? Cos is equal to 0. If you think about the graph of cos, it's 0 at pi over 2. It's 0 again at 3 pi over 2. On the left side, it's 0 at minus pi over 2. Now, what values are falling inside this interval? Let's check that. If we input theta equal to pi over 2 here, so in fact, how can we get pi over 2 inside? One possibility of getting pi over 2 inside could be that the value for theta is pi. So if theta is equal to pi, then this whole thing becomes 0. And that will make all the terms of the sequence zeros. And that's not a standard geometric progression. It's all zeros, right? You could call that an AP as well, or a GP, or any other sequence. It's not a standard GP. Similarly, you could have minus pi over 2 inside if this theta was 0. That also falls inside that interval. So if theta is equal to 0, you would get 0 minus pi over 2 inside. And cos of minus pi over 2, that's also 0. Again, what that would do would be, that will make all of these terms zeros. So if you wanted, you could write down here that these are the possible values of theta for which the sum to infinity would exist. However, there are some exceptions. Theta cannot be equal to 0 and theta cannot be equal to pi. Why? Because in these two cases, you end up getting all zeros in that sequence. Now, it's not necessary to do this. You will still get marks because this is like a fairly advanced thing at this level. If you get these two right, that should give you full marks, okay? However, again, if you're aiming for that distinction, then this would differentiate between two people who have got the same marks. If you've written this, that will give you those extra brownie points for that distinction. Okay, all right, so that's it about this question. That was quite tricky. Let's have a look at the next one. Okay, we want to find the coordinates of the stationary point on this curve, and then we have to sketch this curve. How do you find stationary points of this function? It's a quadratic function. How do you find stationary points of a quadratic function? You could use minus b over 2a, you could use differentiation, you could use completing square, any method that you like. First of all, you could just simplify this. It becomes y equals x squared plus 3x minus 4x, and that's x squared minus x minus 12. Let's find the derivative of this, dy over dx. What's that? That's 2x minus 1. Put that equal to 0. 0 equals 2x minus 1. The value for x turns out to be 1 over 2. What about the corresponding y coordinate? That's y equals 1 over 2 whole squared minus 1 over 2 minus 12. And the corresponding value of y from this, let's see what that turns out to be. 1 over 4 minus 1 over 2 minus 12. And that's equal to minus 49 over 4. That's the corresponding y coordinate. Now the first part was fairly straightforward. The coordinates of the stationary point, what are they? 1 over 2 and minus 49 over 4. Okay, now they want us to sketch the graph of this function. It's a modulus function stating the intercepts with the axes. How do we think about this? First of all, think about the standard quadratic function. We know the turning point is at 1 over 2 and minus 49 over 4. And we know the x-intercepts as well. What are the x-intercepts? Minus 3 and plus 4. Right? You put y equal to 0, you get minus 3 and plus 4 from that. You could mark this point as minus 3. On the right side, you can mark this point as 4. These are the x-intercepts of that graph. It's going to be a U-shaped graph, the original function. And its turning point is at 1 over 2. So you could say it would look something like this. Right? That would be the standard quadratic function. But now you have a modulus. What do you do for that? Because of that modulus, you reflect this part in the middle. And it becomes like this. And you remove that part below. This is the graph of this modulus function. Okay, now you have to state the intercepts. The x-intercept is minus 3 and 4 based on this. Right, you put y equal to 0, you get x equals minus 3 and y equal to and x equals 4. What about the y-intercept? This constant term is the y-intercept. That's minus 12. It was supposed to be minus 12 originally. But when you reflect that like this, it becomes plus 12. So this point here has to be plus 12. Okay, and that's what the graph looks like. That's the second part. Now they're saying, given that k is greater than 0, write down the values of k for which this equation has exactly 2 distinct real roots. Okay, so you want exactly 2 roots. They should be distinct. They should be different. Okay, now how do you find those 2 roots? How do we think about this? Again, you can say this k is a constant, right? So the other function, the other graph that we're looking for is this graph y equals k. That's a horizontal line, right? Now, what horizontal line can you draw here? So you have exactly 2 distinct roots. Given that k is positive, right? K is supposed to be positive. Now, if k is positive, we can only be above the x-axis, right? So I could draw a horizontal line here, for instance. How many roots does this have with the curve? How many points of intersection do you have? 1, 2, 3, 4. That's 4 points of intersection. That's not what we want. We want exactly 2 distinct roots. We can keep going up. At the turning point, we have 3 points of intersection. Above the turning point, we have exactly 2 points of intersection. Okay. So above that turning point, we have exactly 2 points of intersection. Make sense? So what do we say about this then? What are the possible values that we get from this? Above the y coordinate of the turning point. Now, what was the y coordinate of the turning point? The y coordinate was minus 49 over 4. So this point was 1 over 2 and minus 49 over 4. We have to be above this. Okay, so that means the value for k, it has to be greater than minus 49 over 4. That's what you write down there. You say k is greater than minus 49 over 4, and that's your final solution. Okay, that's when you would have 2 points of intersection with that curve. All right, okay, let's move on. Question number 7, part A. Let's have a look at this now. This is from November 2023. This is the next difficult question that I have from one of the P1s in this session. Let's have a look at this now. Y equals x cube into ln x. Find dy over dx. And the first part is relatively straightforward. It's a product. How do you differentiate products? You can use the product rule of differentiation. uv dash plus vu dash. You could say this is u and this is v. U is equal to x cube, v is equal to ln of x. just apply the product rule of differentiation to find dy over dx. X cube remains as it is, into derivative of ln x, that's 1 over x, plus derivative of x cube, that's 3x squared, into ln x as it is, and that simplifies to x squared plus 3x squared times ln of x. Right, that's the first part, fairly straightforward. That's all that you had to do in the first part. Now in the second part they say, hence find this integral. Now again, a very common theme in recent papers where they ask you to find integration of something based on a derivative that you have found in the first part. Now how do you approach this question? Integration of 3x squared into ln x. Now this is a product. You don't have any product rule of integration that you've done in Maths until now. You'll do that in A-levels later on. But we have to integrate this product somehow. How do we do that? We can use the previous part, as the question is suggesting as well, that you have to use what you have done in the previous part. That's what the word hence suggests, right? Now, what have we done in the previous part? In the previous part, what we have done is we have said the derivative of what? Y was this, right? Y was x cube ln x. In the previous part, what we have done is that the derivative of x cube ln x, that is equal to x squared plus 3x squared ln x. That's what we've done in the previous part. Now we want to find the integral of this thing. How can we do that? We can say, let's integrate this whole equation with respect to x. Let's integrate this whole thing. So we integrate this thing, we integrate this, we integrate this. Okay. Now on the left side, you see what happens? This is differentiation, this is integration. They kind of cancel each other's effect, and we're just left with x cube into ln x. On the other side, we have integration of x squared with respect to x, plus integration of 3x squared ln x. And that's what we were actually looking for, integration of this thing. What we can do is we can make this the subject now. Just make this the subject and see what that gives you. Integration of 3x squared into ln of x with respect to x, that is equal to integration of x squared with respect to x. Sorry, the other way around. X cube ln x minus integration of x squared with respect to x. That's what it's going to be. Now we just simplify this and see what that gives us. We have the limits now. We can input those limits after integrating. On the right side, we have x cube ln x as it is. Integration of x squared, what's that? That's x cube over 3. The limits that we had were from 1 to 2. We input those limits here, and that's going to give us the result. Let's see what that turns out to be. Input x equal to 2 once, and that gives you 2 cube into ln of 2 minus 2 cube over 3. Subtract from this the case when you input x equal to 1, and that gives us 1 cube into ln of 1 minus 1 cube over 3, and that simplifies to 8 ln 2 minus 8 over 3 minus ln 1 is 0, so that just becomes 0, plus 1 over 3. Simplify this and you get 8 ln 2 minus 7 over 3. They wanted this form in which a was an integer and b is a rational number, so that's fine. Now in the form that they want, they don't have anything multiplying outside, right? They don't have anything outside with ln. So how do we remove the constant that we have outside? This is 8, right? If you want to get rid of this, we can take it to the power using the power law. We could say this becomes ln of 2 raised to power 8. And now just evaluate that. Ln of 2 raised to power 8, that's 256. So it becomes 2 raised to power 8 is 256. So it's ln of 256 minus 7 over 3. And that's your final answer. That's what we were looking for. That's the integration of this thing. Okay. Let's move on to the next one. This was how many more do we have in this paper? Okay, just 2. All right. So we'll end with these 2 questions from this paper, and then we will do a second part later on. The diagram shows the trapezium OABC, where OA vector is 4A, OC vector is C and CB vector is 2A, the point D lies in AB, the point D lies in AB such that this is the ratio that we're given. This is important to note. The point X is the midpoint of intersection of the lines OD and AC. Okay, so we have that point X. It's given that AX vector is equal to this and OX vector is equal to mu times OD. Find in terms of A and C the vector AB. Okay, now how do we think about this? We've got a diagram given. On that diagram, find a path that takes you from A to B on which we know the vectors. You could say, let's go from A to O, O to C, and then C to B, right? That's the path that you could follow. Okay, just give me a second. I'll be back. Okay, so this is the path that we could follow in order to go from A to B. We could say, let's go from A to O. What would that be? This is 4A in this direction, and the other direction that will be minus 4A. And then from O to C, that's just C. And then from C to B, that is 2A. And that simplifies to minus 2A plus C. That's the vector AB, all right? And then we have to find the vector OD. So we have to go from O to the point D. How do we do that? O to A, and then from A to D. Now, how can we think about this? We could say, in order to go from O to D, let's go from O to A, and then from A to D. Now, the problem is we don't know what AD is, but we have already found what AB is, right? AB vector, that is minus 2A plus C. And we're given some ratios there. They've given us that the ratio AD to DB, that's 2 to 1. So if this is 2 parts, then this is just 1 part. That means if the total is 3 parts, AD is 2 out of those 3 parts, and DB is one out of the 3 parts. Okay, AD is 2/3 and DB is 1/3. So if total is 3 parts, this is 2/3 of the total, right? AD is 2/3 of the total. So what that means is, we could say this is OA vector plus AD could be written as 2/3 times AB. And now we just input values and simplify that and see what that gives us. What's OA? OA is 4A plus 2/3 times AB. We already know what that is. That's minus 2A plus C. Simplify this and that will give you the result. You can see what that turns out to be. 4 minus 4/3. That's 8/3. So we have 8/3 times A. And then 2/3 times C, that's plus 2/3 times C. That's the vector OD that we were looking for. Okay, that's the second vector. Now it says find OX vector. Find the vector OX. What about this now? In terms of AC and mu. Now we've got these information given. This equation and this equation. Where do we have mu? Mu is coming here. So we have to use that to find OX somehow. How do you do that? You already have OD. They're saying OX vector is equal to mu times OD vector. We already know what OD is. So we can say this is mu times OD, which is mu into 8/3 times A plus 2/3 times C. Or you could say that becomes 8/3 mu A plus 2/3 mu C. You could write this directly as well. There's no working required as such. In 1 mark question, you can just write down the final answer as it is. Now what about AX? Now for AX as well, they're saying AX vector is lambda times AC vector. Okay, let's use that now. AX, that is lambda into AC. Now, do we know what AC is? We don't, but can we find that somehow? Can we find AC somehow? Okay, so A to C, we could say, let's go from A to O, and then O to C, that's minus 4A plus C. Minus 4A plus C. Then simplify this, and that gives you minus 4 lambda A plus lambda C. That's the vector AX. Okay, now these were relatively easier parts. These first three parts, fairly straightforward. That's the result that we get from this. Okay. Now, that's it. Okay. All right. So now they're saying, hence find the values of lambda and mu. Hence find the values of lambda and mu. So what we have done is we have found OX in terms of mu here, and we found AX in terms of lambda. How do we connect the two? This is OX, this is AX. Can we find either OX in terms of lambda or AX in terms of mu? We could do that, right? So for example, if we know that this is AX, this is AX. Now, can we also find OX in terms of lambda somehow? We could say, let's go from O to A and then A to X. If we know the vector AX, then OX would be OA plus AX, right? We go in this direction, OA and then AX. Let's do that here. I'll do that. I'll just copy that on the next page then. OX vector, we could say, using this AX vector, we could say OX could also be written as OA plus AX. And that simplifies to OA was 4 times A, 4A plus, or we have minus there, minus 4 lambda A plus lambda C. We could write the OX vector like this as well. All right. So now OX could be written like this. It could also be written like this. That means they should be equal to each other. And that should help us find the values of lambda and mu. Let's do that now. I'll just take it to the next page. Okay, I'm trying to do that. Why can I not paste here? I've recently switched from OneNote to GoodNotes, and I'm not sure how this is going to work. Can I take it like this? No. Okay, so what options are we seeing here? Should be working. Okay, anyway, I think what I'll do is I'll just write that again on the next page. OX vector, we found that to be, so this was, first of all, we said that's OA plus AX. OA was 4A, and we had minus 4 lambda A, I think. Minus 4 lambda A plus lambda C. Now, when you're copying information from one page to the next page, this is a very common place where you have errors, so you need to be careful. This is one vector OX that we're getting. The other OX vector that we had was in the previous part. That was this. Let's use that as well. 8 over 3 mu A plus 2 over 3 mu C. 8 over 3 mu A plus 2 over 3 mu C. That was the other OX vector. We can compare both of them. They should both be the same. Now, what's the coefficient of A that we're getting here? We could take A common. That leaves us with 4 minus 4 lambda times A plus lambda C. This is one OX vector that we're getting. The other vector from there, that's this. This is the other possible OX vector. Right? Now we could compare the two. We could say the coefficients of A, they should be equal to each other. And the coefficients of C, they should be equal to each other. And that gives us two equations. You get two equations. You have 4 minus 4 lambda equals 8 over 3 times mu. And you have lambda equal to 2 over 3 times mu. You solve these two equations simultaneously, find the values of mu and lambda, and that's what we were looking for. Right after this, that's pretty straightforward. I'll leave it for you to do it. So you just compare both of them, and that should give us the result. Walaikum assalam, Khan. Let's move on. That's the last question for this video. I'll do the second part of this, in which I'll do the rest of the difficult questions from this paper, from this session. So in this session, I've covered difficult questions from 2 papers from this session, and the next one, in the next part of this, I'll do the difficult questions from the other 2 papers, inshallah. So that will be after Maghrib. All right, let's have a look at this now. Question number 11. Question number 11, part A. From this paper, this is, again, November 23, paper 1-3. Okay. The first 3 terms of an AP are given by this. Find the sum to n terms, giving your answer in the form k log of 3 base x, where k is in terms of n. Okay, so how do we do this? Now it looks a bit different. It's an arithmetic progression, right? What about the difference of this arithmetic progression? We could say that's log of 81 base x minus log of 3 base x. Could we simplify this somehow? We have minus outside log. It becomes division inside log. So it will become 81 over 3 inside base x. And that simplifies to log of 27 base x. That's the difference that we're getting from this. And the first term is log of 3 base x. We want to find sum of the first n terms. What's the formula for that? Half into n into 2 times a. A is log of 3 base x plus n minus 1 times the difference. The difference is log of 27 base x. Let's simplify this. We have half n into 2 log of 3 base x plus n log 27 base x minus log 27 base x. Okay, let's simplify this. How do we simplify this further? Can we take n common outside? We can't. Okay, we can't take anything common outside. We have to convert it to a single log, right? And inside we should only have 3. All right. So we want to convert it to a single log term, right? So for that, we want to get rid of these numbers from outside. How do we do that? We have half n into 2. We could take this to the power log of 3 squared base x plus log of 27 power n base x minus log of 27 base x. Okay. Now let's simplify this further. That's only 3 more x for some reason. Okay, let's move on and see what we get from this now. I could actually just take this to the power initially. That would have probably made things relatively easier. Okay, let's just continue like this now. Now that I've done it this way, let's apply the log rule. We could say log base x. we have plus between these two terms. So 3 squared is 9 into 27 raised to power n. That's what you have in the numerator, divided by 27. Because we have minus here, that will go to the denominator. Now we simplify this, we have half n into log of, all of this could be converted to powers of 3, right? This could be 3 power 2 into 3 power 3n divided by 3 power 3. That's half n into log of 3 raised to a power 2 plus 3n minus 3, that will be 3n minus 1. Right, now 3n minus 1 goes outside, gets multiplied, and you get half n into 3n minus 1 into log of 3 base x. And that's the final answer that you're getting from this. You could leave it like this, simplify this, both of them are okay, but that's the final result that you've got. Okay, so I made it slightly longer by splitting these two terms. It would be a bit more efficient if you take this to the power right away here. You could skip a couple of these steps that way. Okay, all right, let's move on. Part B. Now it says the first 3 terms of a GP. Now it's different from the first part. The first 3 terms of a GP now. Walaikum assalam. Walaikum assalam. The first 3 terms of a GP are given by this. It has a sum to infinity. If it has a sum to infinity, that means the ratio has to be between -1 and 1. We discussed a similar question earlier as well in the stream. The first 3 terms are these. Find the values of theta for which this GP has a sum to infinity. Okay, so what's the ratio going to be? Second term over the first term. So we could say that's 3 tan square theta divided by 1. The ratio is 3 tan square theta. This has to be between -1 and 1. So we could say 3 tan square theta is between -1 and 1. Divide by 3. So it becomes tan square theta between -1/3 and +1/3. Now again, it's a square, right? A square cannot be negative. So this is actually equivalent to saying tan square theta is actually between 0 and 1/3, right? Because then it can never be negative. So it has to be just less than 1/3. This inequality is redundant. It doesn't even matter because the square can never be negative. This is all that matters, that tan square theta is less than 1/3. Now, how do we solve this particular part of the inequality? Tan square theta less than 1/3. That's what you want to solve now. How do we do this? Let's solve it as an equation first of all. So you have tan square theta equal to 1/3. Solve it as an equation. You get tan theta equals plus minus 1/square root of 3. Now, this is only first quadrant, right? From 0 to pi/2. So all we care about is that it has to be in the first quadrant. Okay. In the first quadrant, we only get one possible value of theta from this. 1/√3, that will be at pi/6. Okay, so that's the solution of this equation. There's only one value that we're getting, that's pi/6. All right. Now, how do we think about this? This is a solution to this equation. What about that inequality? How do we solve that inequality now? We've got a cutoff point, that's pi/6. The other cutoff point would have been minus pi/6, but that's outside the interval, so we don't consider that. We draw a number line. One end point in this interval is 0. The other is pi/2. And this is a cutoff point. This is a critical point that we're having. That's pi/6. Let's mark that somewhere here. This is pi/6. Now, this is the point that is dividing your number line into multiple regions. One region on the left side, one region on the right side. You have to check both of these regions and see which region satisfies, which region does not. You can check that. You can input some value in the middle region. Input some value in the middle region. You could say, for instance, you could use, for instance, in the middle, you could try, this is pi over 6, you could try pi over 12 in the middle. That could be one number that you could try in the middle. Between pi over 6 and pi over 2, you could try pi over 3. You could use decimals as well. That's perfectly okay if you find it difficult to think of it in exact terms. Check these values if they satisfy the inequalities or not. This is the inequality, right? Let's input that here. Make sure your calculator is in radian mode. Mine is right now. So tan of pi over 12, let's check that. See what we get from that. Tan of pi over 12 and square of that. That's 0.07. Is that less than 1 over 3? Yes, that's less than 0.333. So that means this region is correct. Okay. Try a number here. That's pi over 3. Let's try pi over 3. That's giving me 3. 3 is not less than 1 over 3, does not satisfy that condition. So this region is not correct. So what's the solution then? The solution is going to be this region. We say the final answer that we've got from this is theta between 0 and pi over 6. Now 0 in this case could be included, but that will actually make the whole GP all zeros. So that will not be possible. In fact, 0 is not even included in the original interval that they've given. Okay, so we say it's between 0 and pi over 6, and that's the value of theta that we're getting. The possible values of theta that we're getting, theta should be between 0 and pi over 6 for the sum to infinity to exist. Okay. All right, so I hope that was helpful. We will end this here. This was part 1 of this, and I'll do the second part after Maghrib, inshallah, in which we'll do difficult questions from the other 2 papers from this session, inshallah. And that will be around, I'll start around 7:30 p.m. inshallah. That's it for now. I'll see you again later. All the best for your exam. Allah Hafiz. You can also find other similar videos. In the description below. You can have a look at that playlist. And I'll see you in the next